So let's look at CPU, stand for Central Processing Unit. Three main components are CU, control unit. So what's control unit? Control unit pretty much just we use that for controlling the input. Like for example, if you look at a computer, we have input, process, and output. So this is just a part of the computer here. So input, process, output. Now process, this is like your CPU. It's going to communicate to the storage, which is at RAM. Okay, so this process is part of your CPU. So CUs need to control the data, which is bit. So let's talk about the data again. So we said a smallest unit in the machine is we call bit, right? So it can represent a unit of data. 1 byte equals to 8 bit. Now, when you look at a bit, what's a bit? Bit can represent a light bulb, right? So when you hold data, or when you don't hold the data, right? So CU pretty much just going to control when the data is coming to the processors, right? Processor is going to see if this data need to do arithmetic logic unit like add, subtract, multiply, divide, or any logic like true or false. If true, I do this. If false, I do the other one. Something like that. Making decision for you. Just like a brain of human that can add, can make decisions. And human has a control part too on the brain. So when the data come in, if it's need to do some arithmetic logic unit, it will calculate that. And then CU is going to process next to if it's need to store into the storage. But when we do that, it's pretty much just to store into register first. Just like our brain, if I have the number for you, number 10, like 10 pretty much input to your brain. So CU input that, move that 10 and put into register. You still remember 10 just like register holding that 10. And then we said we want to add. Okay, now you remember in the register we said, hey, I want to add. Because CU take the input, right? Say add. Could be from your ears in terms of human brain, but in terms of the computer, it could be from the keyboard, right? And then I give you another number like 20. So CU take that 20 and put into register again. So this register is not a storage here, it's inside the CPU, okay? So we're not talking about storage like RAM and hard disk yet. So it's going to take that data, 20, and add them with ALU. So ALU add 20 and 10 and put into the memory again as 30 inside the registers. And then it's waiting for how would you like me to output. It could set out to the speaker or the monitors. So or you want to put in storage, like save to the file, right? So if you need to put into the display, just CU just take that data and display into output. If you need to make a storage of that data, After you sum, you save the values. Then see you take that and put into a RAM first. Now when we talk about memory or storage here, there are primary storage, or we call memory, and also we have secondary storage. So primary is RAM. Example of that stand for random access memory, and secondary is ROM, read only memory. So example of RAM, this is a computer RAM, and ROM. It could be your flash drive, it could be your disk, CD-ROM, DVD, right? And hard disk. So those are ROM. CD-ROM, hard disk, right? So we come back to here, right? So like we said, oops, sorry. So now let's look at what's the difference between RAM and ROM. So RAM is volatile. So what does it mean, volatile? It's a type of storage whose contents are erased when the system power is turned off or interrupted. Like I'm typing something and then it's blacked out, or someone happened to kick out your power cord for the computer, and I didn't save my program or files that I typed. So everything that you see is still in the RAM until, like, if I type something, if I turn off now, you see that node I'm gonna lose it, because this is still in the RAM until I do file and save, and I could save into my external flash drive or my hard disk. These are ROM. So question is, when you buy a phone, right? You said iPhone 6s Plus. Okay. It's 64 gigabyte. What is this? Is it the register? Is it the RAM? Or is it ROM? This 64 gigabyte. Now, this 64 gigabyte, I mean, if you like to take a lot of pictures, you need a big memory, right? Now when you turn off your phone and you turn it back up, you still see the memory? Your pictures? Yes. So that is ROM. Right? Because the property of RAM is volatile, right? We just talked about that. Now let's look at is volatile. Right. That means if you lost the power, you lost the data. Now why do we need RAM? So we can start to compare. Again, I like to compare this to human brain. So in human brain, we said CPU is the part that I receive the data, and I put into my register as a memory, right? This is still in your brain. Let's say I start to say a lot of things in my class. None of you actually sitting and listen until the end of the class. You happen to have a RAM, which is your notepad, that you jot down. So this is like a RAM that computer use too. When the register is full, they cannot remember any more data. Same, your brain cannot remember everything. You start to put it into the RAM. That's the same behavior, right? So you start to jot down. So I'm gonna bring the image back, right? So like we did, right? We have to put it into the storage, could be RAM. So that's what you do when you do jot down, right, on your notepad. Now, RAM is also volatile, just like your notepad. Your notepad is like scratch paper, where sometimes if you not organize it well, like if I save this file, I pretty much organize it. I create a folder for it. When you go back home, you start to put it into your folder or on the bookshelf or wherever you organize your class. You say, hey, this is CSC110 folder, and I put this note inside here. So I should be good, and this is my Chapter 1 notes or lecture week 1. Then I should be good, right? I don't have to worry about that I'm losing it. Now I can close this, just like you don't have to worry about if you happen to organize your notes from the scratch paper. If you jot down the phone number, you go back, you put in your phone book, then you should be good, something like that, right? So that's comparing to the hard disk or secondary storage. Now let's take a look at this. So we just learned what CPU. Intel Pentium Dual Core. That is CPU. And this is the speed, right? 3.06 gigahertz. So this is the unit. Giga is, this is matrix, right? Kilos, thousand, mega, million, giga is billion. So the higher the number is, the faster the CPU is. Like to process that input, process and output. It's going to do it very fast. Now, the second part, this is RAM that we just mentioned. Random access memory. So this is the size of RAM, 4 GB. And that's the speed. Megahertz, hertz is all the speed, right? SDRAM, static. So let's look at, we have DDR SDRAM. We have SDRAM and DDR. Right, so let's just look at SDRAM. Synchronous DRAM is a generic name for dynamic random access memory. So DRAM is a dynamic RAM. S is synchronous. So, and we also have DDR.